Good evening, and welcome to Story of the Cosmos. Tonight, we drift out to a small, icy moon of Jupiter to sit with a secret it has kept since before there was anything on Earth to keep secrets from. A raindrop falling on this moon would land in darkness that has never once seen light. Because beneath miles of frozen crust, on a world where the sun arrives 25 times fainter than it does here, an ocean has waited. Not for a season, not for an age, but for 4.5 billion years. Longer than mountains have risen and worn away on Earth. Longer than oceans here have filled and emptied. It was there before the first cell divided in any sea we know, and it has stayed hidden ever since, sealed under ice, touched by nothing we have sent, seen by no one. There is no light down there to speak of. No sky, no weather, no passing days, only pressure and cold stone, and water that has never once felt the warmth of a star on its surface. Whatever moves in that darkness moves without witness. Whatever shapes are down there have been shaped slowly, patiently, by forces we are only beginning to understand. We are so used to thinking of oceans as things beneath open sky. This one has no sky at all. It has only ice, and the memory of ice, going down and down until water finally begins. Tonight, we settle into that stillness, not to rush toward answers, but to let this hidden sea simply be what it has always been, quiet, ancient, and utterly alone in the dark. A world within a world, waiting. A raindrop of sunlight here would still be 400 years too late, because it was January of 1610 before anyone on Earth even knew this darkness existed. Galileo Galilei was pointing a telescope he had built himself, one that magnified barely 20 times, little more than a spyglass, toward Jupiter on a winter night, expecting to see a planet and nothing more. Instead, he saw 3 small points of light strung close beside it. Then, within a week, a 4th. Night after night, he watched them shift position, drifting one way and then another, always tethered to Jupiter, never to the stars behind them. By the 15th of January, he understood what he was looking at. These were not stars at all. They were moons, small worlds circling a world that was not Earth. It is difficult now to feel how strange that idea once was. For most of human history, everything in the sky was assumed to circle us. Galileo's 4 wandering lights quietly broke that assumption. When he published his findings that March in a slim book called The Starry Messenger, he gave humanity its first proof that Earth was not the center every orbit bent toward. Europa, though it had no name yet in his notes, only a number, was there from the very first night. A point of light, keeping a secret it would not begin to reveal for another 3.5 centuries. That wait ended slowly, and then all at once. In the final days of 1973, and again a year later, NASA's Pioneer probes swept past Jupiter and returned the first close look anyone had taken at this small moon. Blurred, distant, but real. Then, first in March, and again in July of 1979, Voyager 1 and Voyager 2 arrived in turn, their cameras finding something no one had expected. A surface laced with long crossing lines, pale cracks and reddish streaks running for miles across the ice, as though the crust itself had once split open and something had risen up to fill the wounds. No one could say yet what that something was, but the lines were enough. Enough to suggest this moon was not simply a frozen, inert ball of rock and ice, the way its neighbors so often were. Something underneath it had moved. Something had reshaped the surface, however long ago, and left its signature written across the ice in a language no one could yet read. A telescope, a few points of light, and centuries later, a photograph of cracked ice waiting to be understood. A spacecraft the size of a school bus once found an entire ocean without ever seeing a single drop of it. In October of 1989, NASA's Galileo orbiter left Earth aboard the space shuttle Atlantis, carrying instruments built to study a giant planet, not the small moon beside it. 6 years later, in December of 1995, it slipped into orbit around Jupiter, and for the better part of a decade, it kept circling back toward Europa, again and again, as if drawn to something it couldn't yet explain. 11 times it came close enough to matter. Some of those passes brought it within about 125 miles of that cracked white shell, near enough to feel Europa's own faint magnetic breath. Because that is what a magnetometer measures. Not water, not ice, not anything a camera could frame. A magnetic field, invisible, wordless, easy to miss. And what Galileo found, flyby after flyby, was strange. The field wrapped around Europa didn't sit still. It flickered, shifted, rose and fell in step with Jupiter's own vast, sweeping field, almost as though something inside the moon were answering back. A dedicated pass in January of the year 2000 tested the idea more carefully still, watching how that response changed as the surrounding geometry changed, and it held. That kind of behavior, scientists came to understand, had one simple and likely explanation: a layer of something that conducts electricity. Not solid rock, not solid ice. A salty ocean wrapped entirely around the moon, sealed beneath the crust, hidden from every eye that had ever looked up at it. It helped to have something to measure it against. Nearby, Ganymede, the largest moon in the solar system, turned out to generate its own magnetic field from somewhere deep within itself, almost like a small planet in its own right. Europa's field was different, weaker, borrowed, induced, not the signature of a churning core, but of a thin, hidden sea, quietly responding to a much larger power next door. 8 years of listening to that flicker, and Galileo had done something no photograph ever could. It had found a sea it would never see. By 2003, the mission was finished. Its fuel was nearly spent, its systems aging, and its long, looping path through the Jupiter system was no longer one anyone could keep steering forever. And here the story quietly turns on itself, because the very discovery Galileo had made became the reason for how its story would end. A spacecraft left drifting might, someday, years from now, wander into Europa itself, and carry with it whatever had hitched a ride from Earth, however small, however unintended. So the choice was made in advance, written into the plan long before the day arrived. On September the 21st, 2003, controllers turned Galileo away from the moon it had spent 8 years studying, and aimed it instead toward Jupiter, into the crushing, lightless pressure of its clouds. The spacecraft that had listened for a hidden sea ended its own working life by falling into the loudest atmosphere in the solar system, so that the ocean it had found could stay exactly as it was. Untouched, unreached, still sealed in the dark, the way it had been for 4.5 billion years before Galileo ever arrived. A machine had all but proven the ocean was real, and then, quietly, it chose to protect it. Europa is smaller than the moon that hangs over your own night sky, and yet everything about it moves differently. Locked to Jupiter's grip, it completes a full orbit in just 3.5 days, a moon on a fast, tight leash, always presenting the same face to its planet, never once turning away. Out there, sunlight itself has grown thin. By the time light crosses the 500 million miles from the sun, it arrives 25 times fainter than it does here, dimmed almost to memory. Even at Europa's warmest hour, high noon, straight under that weak sun, the surface holds near 200 degrees below zero. And that is the mild end. Toward the poles, the cold deepens into something closer to 400 below, a stillness so complete it makes the coldest places on Earth seem almost gentle by comparison. But it is the ice itself that holds the quieter mystery. Scientists who study Europa's surface have found it to be young, startlingly young. Not 4.5 billion years old, the age of the moon beneath it, but only 40 to 90 million years old on top. A blink, geologically speaking. Somewhere else in the solar system, 40 million years is barely enough time for mountains to rise and settle. Here, it is enough time to erase almost an entire history of impacts, cracks, and scars, and start the surface over. Which raises a quiet question that the ice itself seems to be asking. If the crust is this young, something beneath it must still be working. Something must be resurfacing Europa again and again, smoothing away its own past almost as soon as it's written. A world this small, this cold, this far from the sun has no obvious reason to still be so restless. And yet it is. That restlessness is the thread worth following, small, cold, and impossibly young for its age. A moon that keeps quietly rewriting itself. Every 3.5 days, Europa's whole body rises and shifts beneath its ice. Squeezed by a pull it can never fully escape. Europa does not travel a perfect circle around Jupiter. It should. Left alone, gravity would round its path into a smooth, lazy loop, the same distance from Jupiter at every point in the journey. But Europa is not alone out there. Io, closer in and restless, and Ganymede, larger and farther out, complete their own circuits around Jupiter in a rhythm locked to Europa's. For every one lap Ganymede makes, Europa makes 2, and Io makes 4. Always that same ratio, always in step. It is a kind of celestial choreography, precise enough to have held for billions of years. And it means none of the 3 moons is ever allowed to settle into a calm, circular path. So Europa's orbit stays slightly stretched, an ellipse, not a circle, swinging a little closer to Jupiter, then a little farther, over and over. That small variation matters more than it sounds. Jupiter is enormous, and its gravity does not pull evenly on a moon that keeps changing distance. Nearer to Jupiter, the pull strengthens. Farther away, it eases. Europa's icy shell and rocky interior are stretched and released, in a slow tidal breathing that never quite stops. That flexing is friction. And friction, deep inside a moon, becomes heat. It is the same warmth, born of the same gravitational tug of war, that keeps Io nearer still to Jupiter and pulled even harder, erupting with the most volcanic activity anywhere in the solar system. Io wears its heat on the outside, in fire and sulfur. Europa wears its differently, inward, hidden, dissolved quietly into the water beneath its crust, just enough to keep an entire ocean from freezing solid in a place where sunlight barely reaches at all. Even Ganymede, farthest of the 3 and coldest, is thought to owe some warmth to this same resonance, holding its own hidden sea from turning entirely to ice. Almost none of this heat comes from sunlight or from the moons alone. Much of it traces back to Jupiter's own spin, drained slowly outward, first tugging at Io, then relayed moon to moon through that same locked rhythm all the way out to Europa and beyond. A planet slowly giving up a fraction of its own turning so that 3 small worlds around it might stay just warm enough, in their own different ways, to keep changing. A dance with no beginning and, for now, no end. A dance with no beginning and, for now, no end. Under that same restless flexing lies a question of scale. How thick is the shield above Europa's ocean? For 20 years, that single number split scientists into two camps who were staring at the very same photographs. One camp read the long cracks and ridges as evidence of a thin shell, ice measured in single kilometers, flexing and fracturing easily above a sea pressing close to the surface. The other camp studied the same images, Europa's great multi-ring basins left by ancient impacts, and concluded the ice had to be tens of kilometers deep to hold those ring patterns in place at all. Neither side lacked evidence. They simply weren't looking at the same clues, and the moon offered no way to settle it from a distance. The answer, when it finally came, arrived sideways. In September of 2022, NASA's Juno spacecraft passed within some 220 miles of Europa, a brief visit on a mission built for an entirely different world. Juno's real purpose was Jupiter itself, and the instrument that would end up resolving the ice debate, a microwave radiometer, had been designed to read the temperature of Jupiter's deep atmosphere, not to measure a moon's frozen shell. But pointed at Europa, it could do something no photograph ever could: sense the faint warmth radiating up from within the ice, layer by layer, and translate that warmth into depth. Across roughly half of Europa, the radiometer found a shell averaging about 29 kilometers thick. 18 miles of ice, give or take, standing between the surface and whatever moves beneath it. Not thin. Not the thickest estimates either, somewhere the two camps had circled without quite landing on together. And the ice itself told its own story once measured this closely. Juno's data revealed the shell riddled with small fractures, pores and cracks only inches across, laced through the uppermost few hundred feet. Jumbled, broken, restless material, close to what chaos terrain looks like from orbit, translated now into what it feels like from within. But those cracks reached only a few hundred feet down. Against 29 kilometers of ice, that's barely a scratch on the surface. Whatever moves through that fractured upper layer, it never gets close to touching the sea. It's worth sitting with what that means. A thicker shell is not simply a bigger number. It's a longer, colder journey for anything trying to cross it. On the surface, radiation splits water molecules apart, producing oxidants that could, in principle, feed life below. But only if they can reach it. 18 miles of solid ice is a long way to sink, one slow fracture at a time. And it tempers some of the earlier hope that Europa's ocean sits just beneath a thin, permeable roof. None of this fully ends the old debate. Juno measured only part of the moon, and ice shells may not be the same thickness everywhere. But for the first time, scientists had something more than interpretation. Not a reading of photographs, but a direct measurement, taken by an instrument that had never been asked to look at Europa at all. 20 years of argument, narrowed by an instrument built for something else entirely. A yellow stain no one could name for 20 years turned out to be something as ordinary as table salt. Not a new mineral. Not an exotic compound born of radiation and vacuum. Just sodium chloride, the same crystal that sits in a kitchen shaker on Earth, spread across a region of Europa's crust called Terra Regio. Scientists had studied that yellowish patch for 2 decades without seeing it clearly, because Galileo's instrument had been built to look at a different kind of light. The salt had been sitting there, in plain view, in a part of the spectrum nobody had thought to check. It took the Keck Observatory and Hubble, working together in visible light, to finally notice what had been hiding all along. Salt alone was suggestive. But salt is easiest to explain not by anything happening on the ice or blown in from outside. It points, most simply, toward water reacting with rock, somewhere far below, at the bottom of that sea. A few years later, another instrument turned toward the same patch of ground and found something else. The James Webb Space Telescope, in September of 2023, detected carbon dioxide, frozen, concentrated, sitting in that same young, broken terrain. Carbon dioxide does not last long on Europa's surface. Radiation breaks it apart, sunlight scatters it away, and comets and asteroids can only explain so much of it. Which meant it likely hadn't fallen from above, it had risen from below. Carbon is one of the plainest ingredients of life, as we understand it. And here it was, seemingly delivered from the ocean itself, surfacing in the same place the salt had appeared, as if the ice, in this one spot, were a thin window onto the chemistry of the sea beneath it. Put together, salt and carbon start to sketch something quieter than a discovery and larger than a clue. A seafloor, perhaps, not unlike the ones we know at home. On Earth, in 1977, researchers exploring the Galapagos Rift found entire communities of life clustered around cracks in the ocean floor, thriving in absolute darkness, drawing their energy not from the sun, but from heat and minerals rising out of the rock itself. Hydrothermal vents. Life that never once needed daylight. Nobody claims Europa has the same. The evidence is chemistry, not biology. Salt and carbon dioxide, not cells or metabolism. But the ingredients being discussed are the same ones that here turned out to be enough. It is worth sitting with what that means. A sea sealed away for 4.5 billion years, never touched by starlight, may still be in quiet conversation with rock, the two of them exchanging salt and carbon in the dark, the way oceans and seafloors do, whether or not anyone is there to notice. Small clues. A stain the color of old parchment. A trace of frozen gas in a JWST spectrum. Neither one loud, neither one certain. But together, they are the closest thing Europa has offered so far to a description of what its ocean floor might actually be like. Not barren, not simple, but chemically busy, in the way oceans tend to be. A kitchen mineral and a familiar gas, traced back to an alien sea. Here is the narration for segment 8. In December of 2012, a faint glow flickered above Europa's south pole, and for a moment, it looked almost like breath. A sea this chemically restless raises a different question, though. Not what lies at the bottom of it, but whether any of it ever escapes upward, past the ice, into space itself, where a telescope might catch it in the act. Hubble's spectrograph had caught something unusual that December. A thin trace of auroral light, the kind produced when water vapor drifts high enough to be struck by charged particles. Nothing had been seen directly. No plume, no jet, no visible spray against the dark. Just a signature, faint and indirect, suggesting that something might be rising from below. A few years later, Hubble looked again. In observations taken in 2014 and 2016, astronomers thought they could make out faint, finger-like shapes reaching more than 100 miles above the surface. Thin and pale, gone before they could be confirmed. What made the sighting harder to dismiss was where it happened. The shapes lined up with a warmer patch of crust that Galileo had quietly mapped decades earlier, on one of its passes through this same stretch of ice. A coincidence, perhaps, or a location worth watching. Here it helps to remember what certainty actually looks like elsewhere in the outer solar system. At Saturn's small moon Enceladus, there is no ambiguity. Cassini didn't just photograph the plumes rising from its south pole, it flew straight through them, again and again, tasting what came out. Water vapor, grains of ice, organic molecules, even hydrogen, streaming outward at speeds topping 0.5 mile a second, fast enough to help feed one of Saturn's own rings. By 2015, that data had done something no telescope image ever could. It confirmed, beyond argument, a hidden ocean underneath. Europa has offered nothing so conclusive. No spacecraft has ever flown through one of its plumes, because no one has ever been certain enough that a plume was there to fly through. The evidence has stayed thin, and it has stayed contested. In 2023, when two teams turned the James Webb Space Telescope toward Europa and watched closely for any sign of active venting, they found none. No jet, no spray, nothing reaching upward on the days they happened to be watching. Then, more recently, the ground shifted again. In 2026, researchers at the Southwest Research Institute went back through 14 years of Hubble's ultraviolet observations, hoping to settle the question once and for all. And instead, they found the statistical case for plumes weaker than anyone had reported before. Not disproven, just less certain than it had seemed. So the record now reads like this: a hint in 2012, a shape in 2014, a shape again in 2016, nothing found in 2023, and the case growing shakier again by 2026. Glimpsed, then doubted. Reaffirmed, then doubted again. Unlike its neighbour at Saturn, Europa has never let a spacecraft taste what, if anything, escapes it. The ocean may reach the sky, or it may keep it at arm's length, sealed beneath ice that never quite opens. For now, it stays an open question. 2 spacecraft are already on their way, and neither one will ever touch Europa's surface, so that nothing we carry from Earth can reach that sea. That is by design. Europa Clipper left Earth on a Falcon Heavy in October of 2024, the largest spacecraft NASA has ever built for a planetary mission. Its solar arrays stretched wide enough to span more than a basketball court, and it is not going to land. It is going to circle Jupiter and pass close by Europa again and again, 49 times, some passes low enough to skim just a few dozen kilometers above the ice, gathering what a single flyby could never tell us. Its path there is not a straight line. It swings first past Mars, then loops back for one more pull from Earth's own gravity, borrowing momentum the way a stone borrows speed from a sling. 1.5 years already behind it, roughly 4 more still ahead, before Jupiter's gravity finally catches it in the spring of 2030. It is not travelling alone. A 1.5 years before Clipper launched, the European Space Agency sent its own envoy, JUICE, built to visit not just Europa, but Ganymede and Callisto too, on a cruise so long it will not settle into orbit around Ganymede until the end of 2034. 2 space agencies, 2 spacecraft, launched about a 1.5 years apart, converging on the same small, ice-locked moon from different directions, each carrying instruments built to ask questions the other cannot. And Clipper is carrying something that has nothing to do with radiation shielding or magnetometers at all. Bolted into its structure is a metal plate engraved with a poem. Ada Limon wrote it, in her own handwriting, called simply, "In Praise of Mystery." Beside it, the Drake equation, copied out by the astronomer who first wrote it down, and beneath both, a small silicon chip, stenciled with the names of more than 2.5 million people who asked to come along, in whatever way a name etched in silicon can be said to arrive somewhere. A tribute to a planetary scientist who spent his life studying icy moons rides there too. None of it will ever be read by anything living. It is not addressed to Europa exactly. The ocean will not open the vault, will not learn what a poem is. It is more like a bottle sealed and thrown into a sea so vast that whoever finds it, if anyone ever does, will not be us. And still it went. Still, 2 space agencies decided that a mission built to weigh ice and measure salt should also carry something that could not be measured at all. For 4.5 billion years, Europa kept its questions to itself, indifferent to who was asking. Now, at last, 2 spacecraft are crossing the dark specifically to ask them properly. Beneath the crust it has worn since before Earth's own oceans existed, Europa's sea has never once seen the light of a star. Not one. Not for 4.5 billion years. It began in the same slow gathering of rock and ice that built every other world circling the young sun, and somewhere in that gathering, heat and gravity conspired to keep a layer of water from ever fully freezing. While Earth's oceans caught their first sunrise, filled with rain, gave rise in time to everything that has ever lived here, Europa's oceans simply settled into the dark and stayed there. No tide has ever caught the light of a moon of its own. No wave has ever broken under open sky. It has only ever known the low groan of ice above it, and the patient, endless flexing that keeps it from turning solid. We have learned enough to be almost sure it is there, salt on a distant shell, a magnetic whisper, a shell of ice thick enough to hide it, and thin enough, perhaps, to one day let something through. But knowing a thing exists is not the same as knowing what it holds. For now, that answer stays where it has always stayed, sealed beneath miles of ice, circling a giant planet in a silence 4.5 billion years deep. 2 small spacecraft are still crossing the distance toward it, carrying our questions the way a bottle carries a note across an ocean of its own. But that arrival belongs to another night, another story. Tonight, we only picture the sea as it is right now, dark, cold, hidden from view, indifferent to the fact that anyone is even wondering about it at all. Somewhere above it, sunlight is falling on Jupiter's clouds in colors no human eye has framed quite this way before. Somewhere below, none of that light has ever arrived, and none of it needs to. The ocean keeps its own time. It always has. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you, until the next journey.